MAP4C 3.0 Two Variable Data Introduction. In this chapter, what we're going to do is learn about different types of graphs and ultimately be able to analyze two variable data using the correlation coefficient and linear regression. So interpreting graphs. Data can be presented in a variety of ways. Graphical representations can include bar graphs, histograms, scatter plots, and circle graphs. So what we first see here in this example is a bar graph, but it's a double bar graph. We can tell this because we are comparing in the years 2007 to 2008, as well as 2008 to 2009. These bars are given in pairs so that we can see the increase in tuition for a community college based on various programs. So what do the red bars in this graph represent? The red bars represent the tuition costs in 2007 to 2008. So this is a legend here which explains what the components of the bars mean. The blue bars represent the tuition prices in 2008 to 2009. B, for which program did the tuition change the most? Now, you can see the change in tuition from one year to the next based on the increase in height. So the y-axis represents tuition, and the biggest difference between the heights, although it's not very significant, we see the television and film increased the most. So that's the program. Estimated tuition for photography in 2007 to 2008. So 2007 to 2008 is red, and photography, this program is here. So estimate the tuition, it's approximately equal to, and if we trace this grid line across, it's approximately equal to 6,000. Now, an advantage of a graph is that you can communicate a lot of information about all of the data using just an image. But we lose a little bit of precision. As you can see, we're not able to approximate to the nearest dollar using this bar. Pay attention to the Y scale. How much does it change for each one unit or one grid square that we move? And the answer in this case is 2,000. So be aware of your X scale and Y scale whenever they're numerical values. Next, although this looks like a bar graph, this is referred to as a histogram. Do you know the reason why? The answer is that each of the bars represent an interval. So when data values are infrequent, if we see here we have heart rates between 120 and 180 units, it's not likely that we have the exact same heart rate for two of these runners. So we can group data values into intervals to better understand the distribution of data. Here we see the most frequent, how many runners had heart rates between 140 and 149 beats per minute. So 140 to 149 is this interval, and the frequency or number of runners is 3. So again, we lose precision. We don't know the exact values of the heart rates in this interval, but we do get a better overall understanding of the distribution of the data. So where the most runners lie. So that's the advantage of using a histogram and using these intervals. What interval was the most common? Well, the most common is the most frequent. So from 160 to 170, we have the largest number of runners, 4. So 160 to 169. What were the minimum and maximum heart rates of any of these runners could have had? So as mentioned earlier, we don't know the exact values within these intervals, but we know that potentially we could have one on this endpoint, 120, and as a maximum on the right endpoint at 180. Miguel surveyed 250 high school students about how they usually get to school. He displayed the data in this circle graph. So I'm going to first start by saying that the advantage of a circle graph is that it shows the relative proportion. It talks about parts out of the total. So what does the light blue area represent? Is it more or less than half the graph? So this is our light blue area, and it's less than half because half of the circle is a straight line across. It also includes the percentage, which is 41%, so that's less than half. And what conclusions might you make from this graph? That the majority of students take the bus, and that a very small group uses public transportation or another method of transportation. Next, scatter plots are an example of two variable data where we're comparing one numerical value and another, and we're trying to identify long-term trends. You can kind of see with your eye, you'd expect that the next few data points would be down and to the right. This would be referred to as a negative correlation. We'll get into this topic in further depth later on. The scatter plot compares the mass and price of a selection of laptops. What does each point show? So we'll take a look at one point and see what it's telling us. On the x-axis, this is telling us its mass, and on the y-axis, this is its price, or suggested retail price. So this is two variable data because there are two numerical quantities attributed to each laptop that we sample in a survey. How many of the laptops have mass less than 4,000 grams? So 4,000 grams is here, and left of that is how many there are that are less than 4,000. So 1, 2, 3, 4. I'm going to include just a line to show that division. So at this point, there's 1, 2, 3, 4 to the left of this. The next component of the question says how many of these cost less than 1,250. So we can also look on the y-axis because now we're given a constraint involving prices. And how many of these cost less than 1,250? We're looking less than down, and the region that would satisfy both these constraints is here. There's one case that is less than 1,250 and less than 4,000 grams. Next, how many of the laptops have mass greater than 4,000 grams? So here's 4,000 grams. Again, we already have this line. Greater than is on the right-hand side. Positive values for the x-axis are on the right-hand side. How many of these cost less than 1,250? 1. That's the same dollar amount. Notice that horizontal bar. 1, 2, 3, 4, 5. When 100 students were asked to identify their leisure activities, what is the sum of the numbers in the second column of the table? So you can take your calculator, add 12 plus 32 plus 83 plus 55 plus 41, 223, which is surprising because 100 students were asked to identify their leisure activities. Why would a circle graph not be a good tool for displaying these data? And if you can recall, the circle graph is showing you the relative proportion or percentage of the total. But that's under the assumption that each element or each person falls into exactly one category. If there's 100 students asked about their leisure activities and we have a sum adding up all these numbers of 223, that means that some people have selected multiple options, which then you cannot talk about percentage of the total. What type of graph would be good for these data? And I would say a bar graph because this is categorical data, labels, names, types. And then you can compare their actual amounts side by side. So remember, bar graphs amounts, circle graphs percent of the total. Next, working with slope and line graphs. Slope is a measure of the steepness of a line. A positive slope means that the graph goes up to the right. So as x increases, y increases, going up. And a negative slope means that the graph goes down to the right, like you see in this image. So that will be helpful for us, not only with drawing lines, but also when we talk about correlation. Now, a linear equation is of the form y is equal to mx plus b, where m is the slope and b is the y-intercept. There are two definitions of slope here. We have rise over run, which is helpful whenever we have a grid like this with a relationship of one grid space represents one unit. As you can see, both the x and y scale have a unit of 1 grid space represents 1 unit. So it's helpful for counting. This goes rise over run down 2 and over 3. So rise -2, run 3. It's advantageous to use this form here that we call the point slope formula. Whenever we have 2 points, we could refer to this as x subscript 1, y subscript 1. Subscripts are used as names in mathematics for variables. And this is x subscript 2, y subscript 2, just meaning that the second point is on the right. And y2 minus y1 gives you the height. x2 minus x1 gives you the run. So that's applied here, and you can see how it works out. Next, write the equation of the line in the form y is equal to mx plus b. Well, b is the y-intercept, and we can see by looking at this graph that this is the point in which the line intersects the y-axis at 8. So b is equal to 8, and that's the one missing component to be able to write our equation y is equal to mx plus b. Let's try on these examples. We're trying to get the equation y is equal to mx plus b for these lines. So the y is equal to, we're going to need mx plus b. So m is the slope. The rise between these 2 points, notice that they're right on these grid lines, so we can identify them without question. The rise is 1, 2, 3 over the run, which is 1, 2, 3, 4. And we write x and find some space. Okay, so it looks like y is equal to 3/4 x plus b. Remember that b is the y-intercept. Here we can see that it's crossing at the point y is equal to 5. Next, with our next equation, y is equal to, and the rise is down 1, 2, and the run is 1, 2, 3, 4. Now this can be reduced as a fraction. -2 over 4 is the same as -1 over 2. And we could have used any 2 points that are on the line that are correctly identified. And the y-intercept in this case is 6 because that's where it crosses the y-axis. Good luck.